Hello friends, this is Suresh and I will talk about today activation function that the type of activation function like Sigmoid, ReLU, LeakyReLU and Softmax. So before we start activation functions, I will go through brief about biological neurons and compare it with our in machine learning, deep learning terms of mathematical function that produced by scientist Roshan Paul. So this is the biological neurons, and these are two biological neurons. So these are input and output connections. We can say as an input, we can say output. So dentries as an input and terminal actions are output, and that are information flow, and that are cell bodies. So that so this brief about particular neurons. If the two neurons flow the information, so how they flow the information? So they flow the information using these connections that calls like synapses. So this that call connection in terms of in deep learning in neural network. So in mathematical terms we are using y is equal to wx plus b. So fx is the function of fx is a function of that operation of neurons where input and weight are multiplied and summation of the base. So this is the brief about of the and difference between the like how we are comparable actual biological neuron and in artificial neuron. Yep. So here the flow diagram of particular particular layer. So this is the A1, A2, A3, the previous like we can say as an input, and W1 that call weight, and summation of the particular operation y is equal to that called wx plus b, that using that equations and pass to the activation function and finally get the output. Yeah, so this is the brief about the where activation function put in the neural network. Now I will talk about what is exactly activation function, and what is use of this, and how it will help for training and update the weight. So here the first terms I will use that called term of nonlinear. So non-linearity, for example, if the activation function is non-linear, then two layer can be proven to be a universal function of approximation. So if there are two, if we use activation like a this that called unity step activation functions, there you can't do that that not differentiable. Also if you use that, then one layer, second layer, third layer called that not called as a difference layer, that is called a single step of the layer, that is called one step of network. So here non-linearity provide for every layer to getting approximation. Yeah, so second term in terms of range. So what will be the output of particular activation function? So in example, like it should be range a real number, it range 0 to 1, yeah, minus 1 to 1, yeah, greater than 0. So that's so what should be the range? And range also matter for particular kind of neural network. Third terms like continuously differentiable. So every gradient based training, so generally in neural network in deep learning, so we use the gradient descents for updating the weights for backpropagation. So it should be differentiable. So whatever activation function we are planning to use, it should be the differentiable. So so then we can differentiate easily and get the results. Another term like monotonic. So monotonic, like it's the function, it should be like the function which either entirely non-increasing or non-decreasing. So I will take some example in the further. So this is list of the activation function people are used. So and most popular I will talk about few of activation function. These are most popular in the machine learning and deep learning. So this is the list, and there are the many activation function and many purpose people are using for that. And there, and every activation function has their drawback and advantage both. So first I will talk about the Sigmoid function. So Sigmoid function, that output range is one, like output range that called 0 to 1. So it will produce output as a 0 to 1 as a take input. So x is the input, and 1 upon 1 plus e power minus x, that called Sigmoid function, and it's the differentiable. So differentiation of the fx is equal to fx and 1 minus fx. So that's the differentiable. Yeah. So one of advantage of Sigmoid function, so it's very simple, is simply differentiate, and it will shrink the value of output 0 to 1 and easy to use. And another drawback, if we thinking about create a deeper network in terms of deep learning, so in deeper network they might be using this if we're taking the derivative of these functions and the output also shrinking, so might be the information the problems, like we have to propagate the information from one layer to another layer, and might be the information can be lost, yeah, completely lost. So the loss of the information, that problem happen in Sigmoid if we go deeper. Yeah, so it will fail, and the gradient might be die, and training might be not there are nothing. If the no gradient, then if not updating the weights, so training training accuracy also not increasing. So here these conditions Sigmoid fail. So in terms of the deep learning, people are using that called rectified linear unit. So it's have its own advantage and disadvantage. So advantage, I will first talk about the advantage. So here the range of activation function that called ReLU, that 0 to 1, where input of x greater than 0. So if input of x less than 0, so it will produce output as a 0. And if the greater than 0, then it will produce output exactly whatever row value we are the passing, and it's differentiable apart from x is equal to 0. So it that corner case handle, like x is equal to 0, there corner case handle whenever we write the algorithm for ReLU. So this is all about the ReLU, and the problem of the ReLU, I will talk about that. That called sometime gradient, like that called tying the ReLU problem. So it might be the like data is sparse or whatever the problem. If ReLU die, then it will not pick up again, and it flow the information 0 again to again, and your training not going well. So for that problem, some people using the LeakyReLU. So leaky concept here using, like generally it should be ideally this type of function that called y is equal to x for x greater than 0. But if x less than 0, so equation will be y is equal to ax, where a called leaky parameter, like parametric. So y equal to 0.01 x. So that like dying problem, that problem solved by the LeakyReLU, parametric ReLU, this kind of function. So this is about the ReLU, rectified linear unit. Now I will talk about the Softmax. So Softmax is a very interesting, and you people all heard about the Softmax function. So every most of the deep learning in classification tasks, other tasks, people using for final prediction output as a Softmax. So Softmax is the probability distribution between the 0 and 1. So it is not only maps the output to 0 to 1 range, and but also map each output in such a way that total sum of equal to 1. So yeah, so equal to 1. So here you will see the Softmax score like 0.12337, and it will get and this is called the input. So here output also sum of all the output. For example, we are getting 10 output, so sum of the 10 output should be 1. So the equation of the softmax is equal to the probability of input z is equal to e की power j I summation of j equal to 1 till k e power j uh, e z. So this is the equation of softmax, and finally it will use for especially prediction the classes. So this is all about activation function. So I talked about I right now summarize things. So in the summary I will talk that activation. So what is the activation? Activation is activate your layer output. There in terms of next you can take a gradient, and that gradient can be used for update the weights. So that's called activation function. Activation property should be property like non-linear, and it's a range. So range also decide whatever use case. Activation function should be differentiables, and if not differentiable some case, so we need to handle that cases. And third, like monotonic functions, so it's better like it's a monotonic function. So this is all conclusion and summary. Yeah, so thanks for watching the video and join the meetup. Yeah, thank you.